Ever wondered why time seems to slow down when you're stuck in traffic but speeds up when you're chilling on the couch? Well, it's not just your perception playing tricks on you. There's a real invisible puppet master at work here, and its name is gravity. You see, gravity isn't just about pulling apples from trees or keeping our feet on the ground. This omnipresent force also tugs at the very fabric of time and space. Picture gravity as a puppeteer, deftly pulling on invisible strings, manipulating not only the physical world, but also our perception of time. Whether you're lounging on your couch, or stuck in a seemingly endless traffic jam, it's gravity that's subtly influencing the pace of the clock's hands. And it's not just about your daily routine. This invisible puppet master has a grander stage, the entire universe. So next time you're late for work, you can blame it on gravity. Ever heard of time dilation? It's not a dance move, I promise. Now, to dive into the crux of the matter, let's talk about a little something called Einstein's theory of time dilation. This theory, my friends, is a real mind-bender. It essentially says that time, much like a rubber band, can stretch and compress based on the force of gravity. Imagine a ball, a simple bouncy ball. Now imagine that ball bouncing up and down. Each bounce takes the same amount of time, right? Right. Now, let's say we take that ball and start bouncing it towards higher altitudes. As the ball goes higher, it starts to bounce slower. Each bounce takes a bit more time than the last. Weird, huh? This is a simple way to visualize how gravity affects time. The greater the gravity, the slower time moves. This is what we call time dilation. It's like gravity is the DJ at the club of the universe, slowing down the beat of time as it pleases. If you're thinking, wait, does that mean time moves differently on a mountain than at sea level? Then give yourself a pat on the back because you're absolutely right. Time does indeed tick by a tiny bit slower at higher altitudes, where gravity is weaker. But before you pack your bags and move to the Himalayas, remember, this effect is incredibly tiny. We're talking differences so small, you'd need an atomic clock to even notice them. And this, my friends, is Einstein's brainchild. A theory that has not only stood the test of time but has fundamentally reshaped our understanding of the universe. It's also a handy excuse if you're ever late for a meeting. Just tell them you were experiencing some time dilation. So, if you want to age slower, just live on a mountain. But remember, the air's thinner up there. Ever wondered why your GPS sometimes goes haywire and sends you down a one-way street in the wrong direction? Well, the answer lies in the complex dance between gravity and time. You see, gravity isn't just about apples falling from trees or why we don't float off into space. It also has a profound effect on time itself. Imagine your GPS system as a beautifully crafted, well-oiled machine that needs constant fine-tuning to function correctly. This machine relies on 24 satellites orbiting Earth, each carrying an extremely precise atomic clock. These clocks send signals to your GPS, helping it calculate your exact location by measuring the time it takes for the signals to reach you. Yet, here's where things get interesting. According to Einstein's theory of relativity, time ticks slower in stronger gravitational fields. That means the clocks in the satellites, which are further from Earth's gravitational pull, run ever so slightly faster than clocks on the ground. We're talking about a difference of about 38 microseconds per day. Now that may not sound like much. Still, when you're dealing with a system that requires pinpoint accuracy, even a tiny discrepancy like this can make a huge difference. If not corrected, this time discrepancy could have your GPS thinking you're about 7 miles off from your actual location. So, the clever folks who designed the GPS system had to account for this gravitational effect on time. They built in a correction factor to compensate for the quicker ticking satellite clocks, keeping your GPS readings accurate. But even with this fine-tuning, sometimes things can go a bit awry. Maybe it's a tall building blocking the satellite signal, or perhaps it's some other unknown cosmic hiccup. But rest assured, your GPS isn't out to get you. It's just wrestling with the fundamental laws of the universe to get you where you need to go. So, next time your GPS goes wonky, remember, it's just trying to account for gravity's shenanigans. Ever fancied a trip to a black hole? Well, you might want to reconsider. Imagine gravity as a whirlpool, a maelstrom of invisible force, not just pulling in everything around it, but twisting and warping the fabric of reality itself. Now that's a black hole for you. Just like a whirlpool, a black hole sucks in everything around it, and when we say everything, we mean everything. Even time isn't immune to its grasp. This is the extreme effect of gravity near a black hole. It's so strong that it warps time itself. Yes, you heard it right. Time isn't a straight line here, it's more like a pretzel. But how does it work? Well, it's all about relativity. You see, the closer you get to a black hole, the stronger the gravitational pull becomes. And as Einstein taught us, gravity affects how time flows. So, near a black hole, time would actually slow down. To you, time would seem normal, but to someone watching from a safe distance, you'd appear to be moving in slow motion. And here's the really wild part. If you were to somehow survive a journey into a black hole, which, let's be clear, you wouldn't, but hypothetically speaking, if you did, well, time would cease to exist as we know it. You'd be in a place where the laws of physics as we understand them break down. It's like stepping off the edge of the universe. But don't pack your bags just yet. Let's not forget about the spaghettification. It's the process where, due to extreme gravitational forces, objects are stretched into long, thin shapes, like a piece of spaghetti. So, unless you fancy becoming a human noodle, it's probably best to stay away. And that's the thing about black holes. They're not just fascinating celestial objects, they're reminders of the incredible mind-bending realities that exist out there in the cosmos. So unless you fancy a one-way trip to who knows where, it's best to steer clear of black holes. Gravity and time, a match made in the cosmos, literally. Let's take a moment to admire the beautiful yet complex relationship these two share. It's as if they're the Romeo and Juliet of the universe, constantly intertwined yet forever altering each other's course. Picture this: gravity, the strong, silent type, always pulling everything towards it, never letting go. And then there's time, ever fleeting, always moving forward, never looking back. They're like two celestial bodies in the vast universe, drawn to each other by an unseen force, yet forever destined to affect each other's paths. The tale of their love is etched in the fabric of the universe, a grand cosmic opera where gravity plays the role of the unyielding suitor, always influencing time, slowing it down, bending it to its will. Time, on the other hand, is the elusive paramour, always slipping through gravity's fingers, forever marching forward, never stopping for anyone or anything. Ah, the drama, the passion, the physics, their love story has it all. Comedy when gravity pulls too strongly and time stumbles, stretching and slowing like a slapstick actor taking a comedic fall. Tragedy when gravity's pull is so strong that time is torn apart, creating black holes where time stands still, a symbol of their forbidden love. And let's not forget the action. The constant dance between the two, as gravity tries to slow down time and time stubbornly resists, creating a beautiful cosmic ballet that shapes our reality. Their love story is not just a tale of star-crossed lovers, it's a fundamental principle that governs our universe. They might not send each other love letters or whisper sweet nothings into each other's ears, but their influence is felt across galaxies, shaping our perception of reality. And that, folks, is the epic love story of gravity and time. Remember, they might be invisible, but they're always pulling the strings.